let's talk about some applications of optimization. So first, I'm gonna talk about algebraic application. And I believe the best way to explain it is through example. So let me give you an example and we're gonna start to solve this example together. Hope you help me solve the following problem. The problem says, find two positive real numbers, and we're going to call these two positive real numbers x and y, such that the sum, and you know what do I mean by sum? It means that x plus y equals 12, where the product x times y is as big as possible. So here is our first problem, and let's think about it. I have two real positive numbers. We're going to call them x and y. One information about x and y is that x plus y equals 12. So let me put it inside this red box because we're going to need this information. Something else. I'm looking for the product x times y. This product, I want to make it as big as I can. How to maximize this product x times y. So how to make it as big as I can. So let's think about this problem right now. I need the function. This function can be written in terms of x and y. Clearly, the function I'm looking for, and here is my solution, is f, which is a function in terms of x and y. It can be written as x times y. My problem here is this function in terms of two variables. But we haven't learned yet how to deal with function of two variables. How can I make it as a function of one variable? So I can find the critical points of this function, and after that I can find the maximum or minimum of it. So what do you suggest? Good for you, exactly as you said. Instead of dealing with function of one variable, of two variables, I'm going to deal with a new function just in terms of x. But how? I'm going to replace the second variable y in terms of x using this relation I have above. Take a look above. Above, I have x plus y equals 12. So instead of y, I can replace it by, how can I replace it? Good job. I can isolate my y from this box, and I can write y equals 12 minus x. So my new function, instead of writing x times y, I can write x times 12 minus x. As you can see, I have a function of one variable. This function gx represents the product x times y. But as you can see, I just have one variable, which is x. Maybe I can simplify it for you. So take a look above here. My function can be written in terms of x as 12x minus x squared. And the question is again, when this function will reach its maximum or its minimum. That depends on the variable, on the derivative g prime x. So let me try to find g prime x. You remember how to find the derivative for a polynomial? Right. Instead of 12x, we will take the coefficient, which is 12, and here is the derivative of the first term. Look at the second term, minus x squared. What is the derivative, guys? Good for you, minus 2x. Since you already have the derivative, I can find the critical points. How? Solve the following equation. Derivative equals to 0. And as you can see, I have linear equation with one variable, which means I'm going to have one answer. What is the answer, guys? Good job, Mika. So, you know how to solve this linear equation. 12 equals 2x. What is the solution? Right. Good. I just have one solution, which is x equals 6. But if x equals 6, so what about y? back to your box here, x plus y equals 12, which means y must be 6, 2. It means that these two values will give me critical point. But how can I know if this point is maximum or minimum? One way to check if this solution represents the maximum or minimum is to draw the following table. My function g will reaches its maximum or minimum when x equals 6. And let me see what are my boundaries here from the right and from the left. If I have two positive real numbers, the maximum value for x can be it's 12, because in this case y will be 0 and vice versa. Now, my derivative g prime equals to 0 here, and when x equals 0, then what about my derivative and what about my function g? Let's calculate. My function g when x equals 0 equals to 0 times 12, which means 0. And again, when x equals 12, I'm going to plug 12 here, and I'm going to have 0 times 12, which is 0 again. But when x equals 6, let's plug 6 instead of x here. I'm going to find 6 times 6, which is 36. Now take a look here again, guys. Now, as you can see, g starts from 0, it's going up to 36, it's going down to 0 again. As you can see, this number represents a maximum, right? Good. So, how can we check that this point represents a maximum? You can check that g prime is positive here, it's negative here, and I'm going to leave this to you. How to check this? You can pick up any point you want between 0 and 6, like for an example, 3, and plug it in g prime to find it's positive. Like for an example, above here, if I plug 3, 12 minus 6, I will have 6, which is positive, so that's why I write positive. But if I plug some number between 6 and 12, for an example 9, and I plug it in g prime here, I will have 12 minus 18, which is negative 6. That's why I write negative here. So clearly, this point represents the maximum value. And I can say that x equals y equals 6 will give the biggest product, which is again 36. Any question, guys? It's clear for all of you. So that was one example about algebra. We can explain another example about geometry if you want.